And I'm going to be talking about global change and drylands, and I'm going to be talking, amongst other things, about a concept called desertification. And this was a word that was invented in 1947 by a Frenchman called d'Aubreville, a forester working on the fringes of the Sahara, where he saw evidence like this of land degradation. And after he invented this term in 1947, it gradually became greatly used in common parlance. And in 1977, there was a great international conference on desertification in Nairobi. And then the United Nations Environment Programme got involved. And then journals devoted to desertification started to be published. And a whole industry of desertification developed, and it became one of the great themes of environmental change. And this is scarcely surprising in a sense, because deserts are extremely important environments on the face of the earth. They cover something around a third of the Earth's land surface. They're home to a really rather remarkably large number of people, more than you would think, perhaps 1 billion or so. And also, rather surprisingly, they contain huge cities like Cairo and Karachi. And they're developing fast, in some cases not fast enough, but many are developing very fast as they're exploited for a variety of reasons. And also, of course, what goes on in deserts can impact upon the rest of the world's system. And this is particularly true of something I'm going to talk about to the Vancouver Institute in a night or two's time, which is dust. But in spite of the fact that this word desertification was invented in 1947 and has come into such general parlance, we really don't know very much about it, and there are still huge controversies out there waiting to be resolved. What is desertification? And can you measure it? People try to. How extensive is it? How does desertification spread, if indeed it spreads? Is it a new phenomenon of the last 50 or 60 years, or has it been with us forever? Is it caused by changes in climate? And if so, what sorts of changes in climate? Is it due to humans? If so, which humans? Is it a permanent or a reversible problem? Is it only a problem that afflicts developing countries like those of the Sahel in West Africa? And what can we do about it? Do we go in for grandiose international schemes beloved of UNEP, or is small beautiful? Well, the definition given here by Anders Rapp, a Swedish geomorphologist in 1974, is nice and simple. Desertification is the spread of desert-like conditions in arid or semi-arid areas due to man's influence or to climatic change. And at least that is even-handed with regard to cause. But what do we mean by desert-like conditions? You have a photographic image in your head as I speak of what a desert is like. And I can see into your brains, and there's a sand dune there and a palm tree and a camel, almost certainly. But in fact, is desertification special to deserts and their margins, or is it just a form of land degradation as you find all over the world? And curiously, there are people now who write papers about desertification in Iceland. And there are lots of people in Europe who get money from the European Commission who work on desertification in Greece and Spain and Italy and get very rich on it. So there are problems with what we mean by desert-like conditions. And then there's the problem of extent and importance. How widespread is desertification? Well, Mustafa Tolba, the head of UNEP in 1992, came up with these fairly drastic and gruesome figures. And you can read them without me reading them out. But they're staggering figures which appear to have a degree of certainty to them. And UNEP produced figures not only for the globe as a whole, but for particular parts of the world. And again, you see this wonderful precision, this wonderful certainty being expressed as to the percentage of productive dry land that is being desertified in different parts of the world. To come up with such figures, you need to have things you can measure. So you need to know what your definition of desertification is, what your definition of desert-like conditions is. And I think these figures are largely spurious. And then we get these wonderful world maps of desertification vulnerability, showing huge swathes of the world, in red, for example, where the vulnerability is very high. But vulnerability is not the same as actuality. And when we go back and look at where UNEP got some of these ideas about the speed of desertification, the extent of desertification, we come to one source in one country at one moment in time. Because a man called Lamprey mapped the limit of the desert in the Sudan in 1975 and compared it with the extent of the desert determined by air photography and maps in 1958, and showed, as you can see on this diagram, that the desert had shifted southwards by perhaps the order of 150 kilometres. It's not very far from there to say deserts, not just the Sudan, deserts are expanding at, say, 10 kilometres a year, which becomes 100 kilometres a decade, which becomes 1,000 kilometres a century. And you extend this from the southern Sudan to the whole world. And you come up with magnificent, totally spurious figures of the importance of desertification. One of the problems with this work was that it was based on mapping in one particular year, which may have been particularly dry, and the vegetation cover was very, very much reduced. And in fact, subsequent work by Swedish remote sensors showed quite plainly that in the 1980s, this boundary was in fact further north than it was shown as being in 1975. And it was for reasons like this that my two colleagues in Oxford, David Thomas and Nick Middleton, produced a book, having worked for UNEP, called Desertification: Exploding the Myth. They argued that a lot of the information that had been put forward by UNEP on the speed of desertification, the extent of desertification, was basically spurious. Now, there are lots of manifestations of this spread of desert-like conditions. Not all of them easy to measure, not all of them as important as each other, but important they are. So we have, of course, soil erosion. One consequence of that is dust storm generation, reactivation of dunes. Very, very important is a decline in the palatability of pasture. We get bush encroachment replacing nutritious grass. We get problems like sedimentation behind dams, reducing their lives to just a matter of a few decades. We get irrigation being introduced, causing salinization. We have widespread overexploitation of groundwater, which produces subsidence. We get river basin water transfers, which causes lake desiccation. And we have idiots in large four-wheel drive vehicles disturbing desert surfaces, ruining lichen fields, and so on. What I'm saying here is that there are a huge number of different factors involved in desertification. And most of them here are related to human activities rather than to climatic change. Let me just show you a few slides of the various types of manifestation. Here are some very beautiful badlands called dongas in Swaziland, southern Africa. These are always attributed, of course, to the natives being incredibly stupid farmers, which, of course, they're not. These are actually due to deforestation by iron smelters in the 19th century, who cut down the trees to smelt iron to produce assegais for Shaka the Zulu. They look very fresh, very active, but they're not new. And very wonderful they are to walk around if you're careful. If you're not like this young orthopedic surgeon, you do suffer. And then we get more general sheet erosion. Look at this tree in Baringo in Kenya with its exposed roots. In a matter of not very long, the soil surface has been washed away by tropical rainstorms, and the roots are exposed by a considerable amount. And then we get sand migration, dune reactivation, and this is a colleague of mine, a New Zealander, for scale. It's not quite as frightening as it looks because he's only 5 foot tall. And we get salinization, the spread of salt and waterlogging produced by irrigation. And this is an example from the Indus Valley in Pakistan. This looks like Vancouver today. And indeed, it was described by one British archaeologist, a picture like this, as a satanic mockery of snow. Because that white film you see over the landscape is not snow, but salt, produced by high groundwater levels, produced by irrigation schemes, with evaporation taking place under the warm desert skies, and the salts precipitating out on the ground surface as that great white efflorescence. And up to 50% of the world's irrigated areas are now afflicted by salinization and waterlogging. And then we've had the iconic example of interbasin water transfers leading to the desiccation of various water bodies, both in America and, in this case, in Central Asia. We see the Aral Sea from space in July to September 1989, and again 14 years later in 2003. The water body has been transformed. It's drying up, it's getting more saline, and the saline areas exposed by its desiccation lead to dust storms, blowing noxious materials containing herbicides and pesticides, which cause health problems for neighbouring people. And here it still goes on, the latest image there for October the 5th, 2008. The Aral is almost dead. And there's the dust being blown off its shoreline, causing huge problems of a respiratory nature for the inhabitants downwind. And here we have the degradation I mentioned caused by vehicles. This lunatic driver of mine in Egypt decided he'd drive across a desert pavement, as it's known, causing these tracks to be developed. Tracks which will last there probably for generations. We call this process Toyotaization. And then part of this whole business of land degradation in dry lands is the dust storm. And here is a dust storm over West Africa, and they have huge impacts, which I'll talk about, as I say, in a night or two's time. So we have all these phenomena. And from what I was saying, you can probably see that a lot of them are essentially caused by human activities rather than by climate change. But we need to consider how important current climate changes are for driving desertification in the way that Anders Rapp suggested. Well, if we look at West Africa and we look at the Sahel and look at the rainfall pattern, we have there a line across the middle, which is the sort of mean annual rainfall over a period of decades, and the red bars are the departures of the rainfall for each year from that mean. And we see essentially that when you get up to the mid-1960s, the annual rainfalls are way below the mean year after year after year. And that is repeated here up to 2007. And again, it's since the mid-1960s that we've had the Sahel drought, and ongoing it still is. So we've now had nearly 50 years of the Sahel drought. And that, of course, means a shortage of vegetation cover, a shortage of water, which leads to greater human pressures on the environment and therefore increased land degradation. So this is why quite a lot of people believe that climate change is a major cause of desertification. And the reason why we have this drought period in West Africa is the subject of debate, but it seems to be due essentially to changes in ocean water temperatures during that period. Why that has happened, of course, is another matter. You eventually get back for explanation to the Bible or nuclear physics. But we see here the impact of the drought on dust storms in West Africa. This is some work done by a colleague of mine, Nick Middleton, and the black spiky line in the top diagram is the rainfall trace for Nouakchott in Mauritania. And you see, in spite of the inter-annual variability and spikiness, that there's a downward trend in the rainfall from 1960, which is here, up to the late 1980s. And over that period, the number of dust events, number of dust storms, shown in red, rose from a couple a year to 80 a year. A staggering change in the incidence of soil erosion by wind, which is essentially what produces the dust. And the lower diagram is for El Fasher in the Sudan, which shows essentially the same story. And I did some work with a colleague, Pierre Auxerre. He's Belgian. Fantastic bit of work. He looked at all the wind and visibility records for the Sahara going back to the late 1940s and used this to try and produce a model of the amount of dust being produced at different times since the late 1940s. And you can see the figures there, that if you take the 1980s and 1990s, there was essentially 10 times more dust being produced by the Sahara than had been the case up to the mid-1960s, when, of course, the drought kicked in. And when we look at 1984, what an appropriate year. The amount of dust being liberated into the atmosphere from the Sahara was, I can't do the sums, but colossally higher than it had been in the 1940s up to the 1960s. Colossally higher. That's a boring slide, so's that. We also see, as a result of the Sahel drought, the desiccation of various water bodies. And these are a series of slides of Lake Chad from 1963 through to 2008. And Chad has shrunk and shrunk and shrunk from being a large water body with large fisheries and large irrigation schemes to a body of water which is largely not water and which even a gentleman dachshund could walk across without getting himself too wet in difficult places. So there is some evidence in West Africa that drought has been a driver of environmental degradation. And there are various other climatic factors we should consider. For a lot of the 20th century, people believed that the world got drier in post-glacial times. There was long-term progressive desiccation taking place. We don't believe that anymore. I've mentioned the extended drought idea since the 1960s, which seems to be absolutely fine as a contributory factor in West Africa. And then, of course, there is the possibility that humans themselves have been changing climate by altering the albedo, that's the reflectivity of the Earth's surface, by cutting down vegetation. That by cutting down vegetation, there's less moisture transpired into the air by vegetation, and that we put more dust into the air, which can affect the amount of incoming heat from the sun, which can affect convection, which affects thunderstorm generation, and so on. Well, we don't believe in post-glacial progressive desiccation anymore, largely because, if anything, in the tropics, the glacials were drier than post-glacials. There is some possibility that we are causing climate change ourselves, that there's a sort of overlap between human effects and natural climatic effects. And there was a particularly interesting model developed in the 1970s comparing Gaza and Sinai, heavily overgrazed, with the Negev in Israel, where there were less people, less overgrazing, therefore more vegetation cover. And the argument was that where you got huge overgrazing, a more reflective surface, you got more reflection of incoming solar heat, so the air cooled, you got less convection, you got less rainfall, so that you had a positive feedback effect of human activities on climate. So how important is climate change? Was Rapp right to say that it was one of the drivers of desertification? Well, as I say, I think it plays a contributory role in the Sahel and the Sudan belt of Africa. But equally, if you go to some parts of the world, there's no downward trend in rainfall evident in recent decades. Though in some parts of the world, notably southern Africa, you see a cyclical short-term precipitation pattern with runs of 8 or 9 wet years, 8 or 9 lean years. And we see that shown here for southern Africa. It's a very different rainfall pattern than we see for the Sahel. So that's something about climate. Now let's move on and think about what the nature of the spread of deserts is. And I alluded to this earlier when I talked about Lamprey's work in the Sudan. And that leads to maps of this sort. Grand, heroic, spurious global maps with deserts spreading outwards. And a lot of people have talked about desertification being like a tidal wave encroaching on a broad front at a sort of near-continental scale. But is this right? Or is it a local phenomenon caused by local people at the local scale? Is it more like a rash, or as I suggest here, Dobie's itch, than a great tidal wave? So going back to Lamprey in the top diagram there, we have what Middleton and Thomas called the myth, and in the lower part of the diagram we have the reality, with desertification occurring essentially locally as a rash. This is very important in terms of solutions. If you're trying to solve the problem, what you do to deal with one is very different from what you would do with the other. And there's been a tendency for UNEP, I think, to take this rather broad front view and to advocate broad front solutions, like huge green belts of afforestation, whereas maybe the solution involves smaller solutions at the local scale. There's also the question about whether the process of desertification is irreversible. Some people argue that deserts are in fact resilient because they've evolved plants and so on that are used to being hammered and can recover quickly when there are good rains. And we saw that with the Sudan vegetation example. I mentioned the Swedes and their remote sensing. If you do get some better years, some deserts are resilient and do recover very quickly. On the other hand, there are some deserts where you can see, for example, the tracks left by British wheeled vehicles during the First World War. They're still there. You can see them in the Egyptian desert. Areas with very thin soils, once the soil's gone, are irreversibly damaged. But one of the quite interesting things that's emerged just in the last couple of years with regard to the Sahel is that it appears to be getting greener again. And there's a big debate in the literature as to why this might be. Is it due to an increase in rainfall? Is it due to better land management? Is it due to farmers leaving the land and abandoning the land so that it recovers? Or is it the result of the spread of nasty, unpalatable invasive species? There's a whole series of arguments being rehearsed now as to why it is the Sahel is greening. Is it because of good things like better land management, or is it because of bad things like land abandonment and the spread of invasive species? And then we come to the question of the human role in driving environmental change in drylands. And obviously there are a whole series of human pressures that are absolutely crucial. Overcultivation, overgrazing, deforestation, salinization, the spread of large urban centres, and recreational activities by people driving over desert surfaces and the like. But even within this domain of human causes, there are controversies. I don't know what you all think about goats. Some people believe that goats are, of course, the most remarkable beasts on the face of the earth. I'm one of them. And the first quote there mentions that. But very interestingly, of course, people have always blamed the goat for desertification. Is the goat the cause or the consequence of desertification? And the literature is full of people blaming goats. Goats nibble away, they ruin the vegetation cover, they cause gullying. Give the goat the benefit of the doubt. They're very light-footed, very broad-minded about what they eat. I think they knacker the land less than almost any other animal. And look at that, they can turn a polythene bag into nutritious milk and beautiful meat. But of course, we have lots of human pressures. The cutting down of wood, major problem all over Africa. We have the use of dung, as in India, for fuel, rather than using it as a fertilizer on the land. And we have the growth of huge cities with their huge ecological footprint. Cities like Khartoum, which require wood and charcoal. Their ecological footprint is enormous. And look at the sizes of dryland cities. Look at their incredible growth over the last 6 decades. And some of the biggest cities in the world today are in dryland areas. A lot of people don't realize that. And that's certainly true in the Middle East, where you've got the growth of cities like Dubai. And they have an ecological footprint. All those wonderful new palm islands and world islands offshore in Dubai require materials, for example, to be built. And so the government of the United Arab Emirates is moving material. Huge quarries in sand dunes, huge quarries in rocky areas, huge quarries in alluvial fans to enable Dubai to build all these new apartment blocks for English footballers and their ghastly wives. Well, they don't all have wives, of course. In fact, none of them do. Well, very few. We won't go into that. But then there's some other interesting questions. What is the role of indigenous people in this whole process? Are indigenous people good or bad? Are nomadic societies good? Are they ecologically sensible? Or are they rapacious and warlike? Do they build up excessive stocks of domestic animals? I don't mean game, I don't think. Cowdolatry, as the anthropologists call it. Are nomadic societies bad because of the tragedy of the commons? No one owns the land, so the land can be knackered. And of course, some of these traditional societies are undergoing very rapid population growth. So some people blame indigenous people. On the other hand, a lot of indigenous people have a whole series of strategies for trying to minimize the amount of damage that's taking place in desert environments. Nomads are mobile. They spread risk over wide areas. They have wide range of different types of herd to make use of different vegetation conditions. They have a society which generates income by using all sorts of natural resources in many ways. They move, which enables one to have periods of fallow. And of course, a lot of indigenous people are not rapacious. They are, in fact, people who try to protect trees as part of their religious symbolism. So there's arguments for and against indigenous people. There's arguments also about population increase and how important it is as a driver. And intuitively we think more people, more animals, more pressures. Blame the number of people. But even this is not without its controversy. And there was a very interesting study done in the Machakos district of Kenya in 1994 by Tiffin and some of his colleagues called More People, Less Erosion. Great title. And they showed that in this area of Kenya, population had indeed gone up dramatically. Livestock numbers had gone up dramatically. The area cultivated had gone up dramatically. But in spite of that, the area, when you looked at photographs from then and now, showed now there were more trees, less erosion, there was more terracing, increased agricultural productivity, and new sources of income had been developed. So here's Machakos in 1937 and 1991. More people had not led to environmental degradation, it had led to environmental improvement. And another big controversy when we come down to humans is how important is colonial and neo-colonial activity? And it's easy, of course, to blame the colonial powers for some aspects of landscape degradation. We imposed boundaries which stopped nomads from moving. We broke down local political structures. We competed with their local handicraft industries. We forced them to plant cash crops by taxing them. We didn't like nomads. They were tricky devils. We wanted to settle them. And we stole their land, in Kenya and elsewhere. And we installed boreholes for good reasons, but that led to overgrazing of vegetation. Another interesting question is desertification, is land degradation in drylands, is it a feature merely of developing countries? We always see the pictures of the Sahel and of Rajasthan in India, but we must remember that it is actually a feature of developing countries and developed countries. And in some ways, high technology can create greater desertification risks. And we saw that in the dirty 30s in the USA high plains, when there were in places like Amarillo and Lubbock dust storms on 100 days in the year during the 1930s, with visibility down to a matter of meters. And this was caused partly by dryness and heat in the 1930s, but also by the internal combustion engine, the tractor, the combine, and so on. And it's still going on in the United States of America. It's a big problem. High-tech societies have huge water needs. They impose huge recreation pressures. We have the expansion of irrigation, particularly groundwater exploitation through center pivot systems. We've got population growth generally because people like living in nice, dry, warm places. I certainly do. Military bases, lots of chemicals in the environment, and so on. Whoops. So here's center pivot irrigation, a new technology, highly productive, capital intensive. It enables you to irrigate what one of my students used to call lumpy ground. Normal irrigation systems depend on gravity, so they're essentially flat. But with center pivot irrigation systems, you pump the water up from a borehole, put it on a revolving boom that goes round and round, and that revolving boom can go round and round on quite irregular topography. Here we've got a U-2 spy plane photo of New Mexico showing an area of old dune fields dating back to drought conditions some thousands of years ago. You see those round fields, and you see some of them are white, and this is due to the erosion of topsoil by wind. So there we have a new high technology, high capitally intensive system of agriculture coming in, causing increased erosion. And the mining of groundwater also can cause huge problems of subsidence in America and in other parts of the world. And this is the picture I like most of subsidence in the San Joaquin Valley in California, where since the 1920s, the land surface has subsided by the height of this room or thereabouts. Then we come on to the question of solutions. Is small beautiful? Is large beautiful? Well, the UN has tended to go for the grand, but in fact, I would argue that most desertification and land degradation is a local problem. You should involve local people, local labour, get local people involved, and there are a lot of people in developing countries to be involved. So there are lots of things you can do to try and ameliorate the environment by creating banks to cause water to be spread out over the land surface. You can build banks to try and stop erosion, again using labour. You can try and develop little stoves so that your need for firewood is less, and so on and so forth. And I want to conclude by just saying a little bit about the future. To what extent are drylands going to be transformed by global climatic change? Well, this is the Intergovernmental Panel map of 2007, showing projected changes in rainfall by the end of this century. And in brown and yellow, you see areas where the rainfall is likely to decrease by 20% or more. And what does one notice? The brown and the orange essentially are related to the major drylands of today. Not entirely, but nearly all the models for the world, for nearly all parts of the world, show that if anything, drylands are going to get drier in coming decades. This is not true for the drylands of northwestern China, but it's true, as you can see there very plainly, for the great belt of desert through the Sahara and Arabia, the Kalahari, and parts of Australia. So a lot of places are going to get drier. Everywhere, nearly, is, of course, also going to get hotter. So if you combine less rainfall, higher temperatures, then you are going to get major problems in terms of water supply and stream runoff. And most models suggest that if you have a temperature increase of 2 degrees, which is pretty conservative, and a precipitation decrease of 10%, which is pretty conservative, a lot of dryland streams will lose 60% or more of their flow. And we see this for southern Africa, the predictions by the Hadley Centre, and in that rather revolting yellowy colour, we see those parts of southern Africa, including the whole of the Kalahari, where runoff may decrease by 60% or more. The implications of that for the water supply of Cape Town and Johannesburg, Bulawayo, and so on, are staggering. It also means that African women, and it is, of course, women in Africa who do all the work, will have to walk further to get water. And it's very likely that the stream network in large parts of dryland Africa will contract in coming decades. Elsewhere, however, we may get increases in rainfall because in a warmer world we may get more cyclones. And that may be the case, for example, in northwest India. But generally speaking, hotter, less rain, drylands are going to get drier, and this means that on desert margins particularly, where there's a lot of old sand dunes dating back to drought periods 15,000 years ago or whatever, there's a lot of sandy material waiting to be reactivated. A lot of dunes, which are now stable, will start to move. And we know they do that because in the Holocene, in the last 10,000 years, there's lots of evidence in America, don't worry about the detail here, that when you've had runs of dry years, like the 1930s, the dunes have got active again. So we have the possibility of major transformations in the world's sand seas. And this is true even of Canada. And there's been some very interesting work done recently by the Geological Survey, or whatever it's called, of Canada, looking at dunes in the northern Great Plains here and showing how the type of dune and the mobility of the dunes have been transformed over periods of a few centuries or indeed decades. So we know that in areas like Saskatchewan, there's great potential for dune reactivation to occur in a warmer world. On the other hand, the activity of dust storms and dunes is also related to wind energy. One of the big questions is, in a warmer world, is the wind going to get stronger or less strong? Well, Chinese studies have indicated that in the last few decades, wind energy has decreased as warming has taken place. And here are trends in sand drift potential for China between 1960 and 2003. And it's really rather good news. All going down. And here's the relationship between mean annual wind speed and air temperature over China since 1969. Again, a rather striking relationship between wind speed and air temperature. As air temperature goes up, wind speed goes down. And this appears to be the reason why. And if anyone's here as a climatologist, I apologize for this noddy and big ears Walt Disney characterization of how it works, but that, I think, is, roughly speaking, what it's anticipated will happen. But there are large tracts of the world's desert margins, the semi-arid areas, which have these old dune fields, which are currently largely stable, which are just waiting to move. And my colleague David Thomas has tried to predict what the Kalahari of southern Africa is going to be like in 2099. Most of the dunes in the Kalahari are ancient. They date back to drought periods of the Pleistocene. They're covered in a reasonable vegetation cover. They're not moving. And yet, by 2099, given what we know about rainfall and temperature, Thomas and his colleagues predict that these old dune fields here, for example, near the Okavango swamps, up on the border with Angola and Zimbabwe, these great linear dunes will become totally reactivated to the detriment of the local pastoral peoples in the Kalahari. So, President Slaymaker, I come to halt. The message is that climate is hugely significant, has been in the past, will be in the future, but we still have huge uncertainties, huge controversies, and although we're fixated these days on climate change, I hope I've shown that at least a lot of what goes on in the world's drylands is driven by human activities. So if I can stop at that point, thank you very much.
Thank you very much, Andrew. Are there questions?
Yes, please. Thank you very much, Andrew, for your talk. I have a question about your response to certain land management techniques. China came into your talk right at the end.
Yeah.
This is a society which has had mass mobilization in the last 25 years against their own problems of desertification by tree planting and the Great Green Belt in the north of China. I suppose, A, what does geographic science say about its effectiveness, and B, whether it can be used in other environments?
That's a very good question. The Chinese have indeed been very active in trying to reforestate quite large tracts of the drylands of northwestern China, and have, as you say, created great green belts. And that is partly a response to the belief that dust storm activity in China has been increasing in recent decades, and partly in response to the belief that it's deforestation that's responsible. Well, the reality is that, in fact, the dust storm trends in China are not upwards. If anything, they've been downward since the 1970s, with a spike in the early part of the 2000s. And the researches of most Chinese scholars suggest, I think, that the reason for the downward trend is not due to afforestation policies, but to changes in the nature of the general atmospheric circulation and the strength of the Siberian high pressure zone, and so on. So some people have tried to attribute the decline in dust storms to afforestation, but I think that is misleading. And I think quite a lot of Chinese scientists are now arguing that, in fact, some of this afforestation is unsustainable in terms of water supply, in terms of what species are being planted, and that it's not being terribly effective. And again, because it comes down to what I was saying about this idea of desertification spreading like this, and even in a command economy, it's not always evident that people who don't have a personal engagement in, investment in, interest in the planting and protection of trees are going to protect them. And they've, UNEP have encouraged the idea of planting a great belt of trees in North Africa, a ceinture verte, a green belt, to stop the Sahara encroaching. One slight problem there, the winds actually blow the opposite direction. I mean, the Sahara isn't coming forward as a great mass from the south. The trade winds are actually going the other way. And it's not moving like that anyway. But you do get these grandiose schemes for reforestation, and local people really aren't necessarily going to be terribly interested in them, I think, and they certainly won't maintain them. So I think they're not necessarily the solution. I don't know if you agree with me on that. That's the method. Okay.
Yes, Goudie.
Yeah, thank you very much. I have a general question. Would you see some advantages of the desert? And the other question is, do you consider all deserts that you have shown us a dead, or do you think that some of them may have living organisms?
Well, there's two questions there. The first one is about whether deserts are, I suppose, important. And I've always loved deserts myself because I think they're extraordinarily beautiful. And related to that is the fact that, of course, they have much more diverse ecosystems than one would think. And they do have great potential for studies of a whole range of organisms, for example, from termites through to antelope and so forth, studies in the Namib particularly have shown the huge diversity that there is, fed by fog water and by dew and organic dust being blown in from the interior. They really are rather interesting and say much more diverse ecosystems than we would normally think. They also have great potential in the world in front of us, I suspect, for alternative energy sources. Solar power, there's no shortage of that. There's no shortage of wind power in quite a lot of deserts, particularly coastal deserts. There's all sorts of schemes for transferring solar energy caught by big reflective mirrors and solar voltaic arrays to Europe. And there's all sorts of interest now too in possibility of using desert depressions like the Qattara Depression in Egypt, which is below sea level, build a tunnel, generate hydroelectric. Now, I have severe doubts about some of these schemes, but there's that potential. And I think there's also huge chemical potential with some of these salt lake systems, for example. And every time you use your mobile phone, I gather it's got lithium batteries or something. Well, a lot of this lithium comes from salt lakes. So there's a lot of resources waiting there in deserts, and with new technologies, particularly I think on the energy front, they could be very significant.
Mr. Goudie, thank you for your talk. You were talking about solutions. You discussed how you saw local ones as being superior than something grand like the UNCCB. Can you elaborate on why you think that is, and what policy steps you think we need to take to overcome the major challenges in curbing desertification?
Yes, I rather skated over solutions because I'm not really very good on them. I'm an academic, you understand. Not of a practical bent. But I think that as I was saying really, that a lot of the work that's been done by people over a longish period, people like Michael Mortimer in northern Nigeria, it's shown that the phenomenon is very largely local in scale. I mean, that's what I was saying. And that there are local structures waiting to be used, and that there are local solutions that have been employed in various parts of the world that can be employed elsewhere. And there are various earth scan books, for example, that suggest that some of the methods of water harvesting that have been developed in the Middle East since Roman times could be used to generate runoff to irrigate in, say, East Africa. Now, East Africa is not the Negev, and one attempt to do this involving Israeli aid to Kenya caused rather severe erosion because the soils and the rainfall regimes were very different than in the Negev. But there are a whole series of local terracing schemes, for example, water spreading schemes, which have been developed in some parts of the world which could be extended to other parts of the world. And I think that that sort of technology transfer is quite important. I mean, my doubts about the United Nations approach is that, you know, they try to get together all these regional groupings of countries which don't always talk to each other, and try to come up with these broad-scale solutions. And I am, I think, in general, a believer in the small is beautiful school. Involve people in their own areas doing the things that suit their areas. I mean, that's the philosophy behind it. I mean, a lot of these big technological schemes for developing deserts, I'm suggesting America, have caused a lot of damage to the environment. I mean, you can get involved in you know, the debate about large dams. Are large dams the solution to desert development? And that could be another hour. Mercifully not. You're not. You obviously know more about it than I do. No?
I'm just jotting down my
Oh,
words.
well. Mm.
Graham.
Andrew, you've persuaded us, I think, pretty comprehensively that the UNEP idea of the desert marching south is a fiction. But in looking at alternative scenarios to understand what is happening on that transition zone, you pointed to Tiffin, but you didn't mention Melissa Leach and James Fairhead's work and their argument that, in fact, the forest is encroaching on the sand rather than the sand encroaching on the forest. I wonder if you'd like to comment on that at all.
I'm always embarrassed as a geographer when anthropologists do work that geographers should do, and Leach and Fairhead worked in West Africa, and in West Africa there was the general view held that the local people were gobbling up forest resources, and that this was causing land degradation. And what Leach and Fairhead did was to go and actually live in some of these areas where it was alleged that the trees were being gobbled up. They also did some remote sensing studies. They also did a lot of archival work and looked, for example, at the accounts of some of the early European explorers in West Africa. And they did show that over extensive parts of West Africa, little islands of forest have been expanding in the last 100 years or so. I hope I'm paraphrasing this right. And that they weren't little remnants that were left. They were areas that were growing. And I always think those two studies, the Tiffin one and the Fairhead and Leach one, are quite nice because they show that in spite of increasing population, indigenous peoples have managed to achieve deliberately, or sometimes perhaps less deliberately, favourable changes in the environment over a period of decades. The way goes back to that question, you know, of involving indigenous people. I mean, we often tend to be rather arrogant about their abilities, but they do live in these countries and they have evolved with them over a very long time period. I think there are some people, though, who criticise the Leach and Fairhead. I can't remember what the arguments are, but I thought it was rather a neat bit of work, but you may feel different.
No, I agree with you and with them on that. It struck me as being a wonderful piece of essentially geographical scholarship done by card-carrying anthropologists.
Yeah.
Melissa Leach does have a geography degree.
Oh, good. Well, it was environmental detective work, really, wasn't it? And I say geographers now don't go into the field long enough and get immersed in people like the anthropologists still in some places do. So I was rather impressed by that study, which is a lovely combination of natural science and social science.
Mm-hmm. No, I would agree, and I think there have been the criticisms that you point to, and I think partly that was driven by their very trenchant critique of the experts, mainly from France, who were coming into this area in the 1930s and misreading the landscape.
Well, there were a whole series of these so-called experts. I mean, d'Aubreville was one of them, the guy who invented this term desertification. And then it wasn't just the French. There was a British chap called Stebbing, who worked in Nigeria or wherever it was, and they were partly fixated by this idea of post-glacial progressive desiccation at that time. That and natives combined, you know, not good combination. That was their view, by the way. That's not my view, that was their view. Just get that straight. Sometimes I speak with irony, and people who don't have the same sense of humour as the British think I'm being a racist pig, and I'm not. Exact opposite. I hope that was clear. Because sometimes I get people, you know, really getting very angry at me. I used the term once when I was giving a lecture about sea level change, going on about Bangladesh being a miserable country. And I was using miserable in the sort of biblical sense, you know? And it is a miserable country in that sense. It's not miserable in the other sense. I have to make these things clear. Sorry.
Mike.
You made passing reference to military tracks in the desert.
Yeah.
In the last 70 years or so, there's been rather a lot of warfare in and around
Yeah.
the deserts. Has there been any significant cumulative impact from the activities of warfare on the spread or maintenance or intensification of desert-like conditions?
There was a very good study done in the western desert of Egypt during the 1940s, which showed that the campaign at El Alamein and so forth led to a substantial increase in dust storm activity for a matter of years. And there was a certain amount of work done as a result of the first Iraq War, particularly by the Kuwaitis, who had a slightly vested interest in the outcome of their investigation, to show how dreadful Saddam Hussein was. And undoubtedly, there were appalling effects in Kuwait of military activity, not only in terms of disturbing the desert surface, which is bad for desert organisms and lichens and so forth, but does generate dust storm activity. And of course, they also led to vast outpourings of oil across the desert surface and so forth. But there's quite a lot of work being done in America now on the effects of the military training areas, with track vehicles and so forth, creating a fugitive dust problem. Just how long-term and extensive these things are, I don't know. But I mean, it was Bagnall, the great British dune man, who, you know, in the 1930s could pick up all the tracks of the British armoured cars of 1916, which were Rolls-Royce armoured cars, and they had double thin rear wheels. And so they're a giveaway. And those still exist in the desert today. So in that sense, you've got a permanent damage to the desert surface, or near permanent. I mean, it's nearly 100 years now.
You have an interesting, exactly the same effect in the Arctic.
Yes.
Well, I think so.
And I mean, when this old devil here, Slaymaker, introduced me in Glasgow, and I gave a talk on dust, and he said it was a very appropriate study for head of an Oxford college. I mentioned that dust was being generated by this process of toyoterization. And I also mentioned those figures that Ozer had got from the Sahara, that the amount of dust coming out of the Sahara had gone up tenfold. And of course, the English newspapers put the two things together. Toyoterization causes tenfold increase in dust storms. They did. And then, of course, it went worldwide. You know, it appeared in every newspaper on earth. And I was hugely embarrassed by that. But of course, it's not true. But I mean, it is interesting that there's a paper come out just last few weeks by Natalie Maherwold, which suggests that the amount of dust in the atmosphere has actually doubled in the 20th century as a result of all these various activities. But military activity was one of them. But of course, it's big in the Western United States, military training areas in the Barbados.
Yes, please.
You brought up the desertification of Iceland.
Yeah.
And I've been there a number of times. There's a number of reasons for that.
Yep.
The major reason is the raising of sheep.
Yeah.
And sheep have the very nasty habit when they eat grass to pull it out by the roots rather than eating the leaves of the grass. And you can see these banks, when you go in Iceland, drive around, you see these banks are 6 feet down.
And you've got these peaty soils being...
The Icelanders are aware of it, but they
they
like
are.
sheep.
They are,
Okay.
yes. And they're very worried about the declare these peatland soils adding to the carbon budget of the atmosphere and so forth. So that they also get money for that research, as everyone does now, if you have the right message. But you're quite right about sheep. You're just reinforcing what I said about goats being extremely nice animals.
Of course, they cut down all the first forests too over the last hundreds of years.
Yes. And they live in a very windy environment.
So you showed some confidence in the IPCC projections, Andrew. And
Well, I use them.
Yeah, given the controversies around the IPCC projections, and noting the tremendous variability of these arid environments, I wonder whether they're even more dicey in arid areas than they are for the rest of the world?
Well, it's not just the IPCC that makes predictions, of course, and there are a huge number of individual modelling studies done, and there's been a paper that I saw just a couple of days ago that's come out by various American scientists, which looks at all the models that have been developed of future precipitation trends for the southwest USA, and they are virtually unanimous on the increasing drought incidence for that part of the world. There are, of course, huge uncertainties. I mean, one big issue is the relationship between global warming and El Nino incidence, and that's not at all clear. And yet we know from what's going on in Australia and South Africa and Sri Lanka at the moment just how important events of those magnitudes are. And if there were to be a change in El Nino, then I think that would be extraordinarily significant. But the research really hasn't been done. There's also huge uncertainties, which the IPCC is well aware of, with regard to future hurricane activity in the world. I mean, one thinks intuitively that if you warm up the oceans, you will get more hurricane activity because there's more latent heat and more energy to drive the tropical cyclone systems. But this is by no means evident. And there are still, two main schools of thought with regard to future rainfall associated with future hurricane activity in a warmer world. So there's still huge uncertainties, and of course a lot of these models are very coarse anyway that we have spatially.
I just had a thought. I noticed some of the projections obviously are to 2099.
Yes.
And a lot of others are to 2050. And I wonder whether we need to be cautious about 2099 projections and note the uncertainties as far as 2050.
I don't know the answer to that, but obviously as you move towards 2099 and being further away, the degree of uncertainty is bound to get bigger. I mean, the worry to me, of course, is that many of our temperature predictions are quite modest. And if China goes on developing at 10% or more a year, which it is at the moment, according to today's figures, it's now burning 2 billion or more tons of coal, 10 times what Britain did at its peak. And if they keep being wedded to a carbon economy, and if you don't get the increasing energy efficiencies that you get with developing economies, then of course looking at a 2, 3, 4 degree centigrade rise in temperature by 2099 may be wide of the mark. And I mean, the worry is that, as you know, as soon as you get to these higher temperature predictions, you can get all sorts of tipping points and runaway positive feedbacks going on, which could make things dramatically worse. And I'm always worried by tipping points and positive feedbacks. I mean, it's more of a problem in the Arctic, but if you get drier so that you get less vegetation, you can set in train various degradation processes which could be self-fulfilling, less vegetation, less transpiration of moisture into the atmosphere and so on. And I mean, that's the worry in northeast Brazil.
Well, any questions? Seeing none, may I take the opportunity of thanking Andrew for his magisterial presentation.